This is the video for Dilations Part 2, where we're looking at finding the scale factor. So in these situations, you're going to be given the pre-image and the image, and you will be making ratios to find the scale factor. So your I can statement, when given the pre-image and image after a dilation, you can find the scale factor by setting up a ratio, comparing the image, which is the new figure, to the pre-image, which was the original. To find the scale factor, you're going to be setting up a ratio. Your ratio should be set up the same each time. So it should be the image, which is your new figure, compared to your pre-image, which is your original. Once you make that ratio, you can simplify it. So if it happens to be 2/6, you would want to simplify it to a ratio of 1/3. Remember that your scale factors, if it's greater than 1, then you're going to have an enlargement. If it's less than 1, you're going to have a reduction. And if it is 1, then the figure will stay the same. We're going to do the first example. We're going to find the scale factor that's used to obtain the dilated segment AB from the pre-image segment AB. So we start out with our original ordered pairs. A is at 6,3, B is at 0, -3. The dilated segment, A will be at 2, 1, and B will be at 0, -1. We're going to set up a ratio, and I did 2 different ways that you could set this up, because you can look at either the X or the Y coordinates. So for instance, I looked at the X and the Y in point A. So we're going to be dealing with point A. So those are the 2 dilated points we're going to use to make a ratio. You can either compare the Y's in that point A or the B's. So I've put both of those examples up here for you. For instance, the Y coordinate for the image of A is 1. The Y coordinate for the original, or the pre-image for A, is 3. So your ratio is 1:3. So that means it's a scale factor of 1/3. We could also do the same with the X coordinates. For instance, the X coordinate for the dilated A is 2, and the X coordinate for the original A is 6. 2/6 will simplify to 1/3. So again, you have a ratio of 1:3, which means your scale factor in this situation is 1/3. Less than 1 means that this segment became a reduction. It's 1/3 of the size of the original. You should also be comfortable in finding a scale factor when you're given 2 graphed figures. So in this particular situation, we have the pre-image, ABC, which is your smaller triangle, and we have the image, or the new dilated figure, ABC, which is your larger triangle. So again, you'd want to make a ratio, and you can choose any of those ordered pairs, A, B, or C. This time, I'm going to work with the ordered pairs for B. Your original B is sitting at 2, 2. And your dilated B is sitting at 6, 6. Remember, you want your new compared to your original. So your ratio, I'm going to be working with the B's, and let's just say we want to use the Y coordinates in that point. Okay? So you're going to set up the Y for the dilated. That is a 6. And then the Y for the original, which is a 2. When you simplify this, we get a 3. So in this particular situation, the scale factor is a 3. And if you notice, since 3 is greater than 1, we should have an enlargement, which we do. So in this dilated example, the image is 3 times bigger than the original. But one thing you want to make sure you do is keep a close eye on how they're labeled, so that you know which is the pre-image, or the original, and the image, the dilated figure. You can also find scale factors from word problems. So we're going to do this one right here. Through a microscope, the image of a grain of sand with a diameter of 25 hundredths millimeters appears to have a diameter of 11 and 25 hundredths millimeters. What is the scale factor? So again, we're going to set up a ratio comparing the image, which is the new, to the pre-image, which is the original. Now, if you think about the problem and what's going on, the new would be this 11.25, because that's what happens when you put it under that microscope. The new size appears to be bigger. So we're going to put 11.25 as our numerator. Our original, or the actual size of that grain of sand, is actually 0.25 millimeters, much, much smaller. So the original diameter we're going to put in our bottom portion of our ratio. Now you're going to simplify this by dividing. So 11.25 divided by 0.25 will give you a scale factor of 45. That is definitely larger than 1, so this is definitely going to be an enlargement, which typically makes sense because that's what we use a microscope for. So this particular microscope enlarged that grain of sand 45 times bigger than its original size. We're going to look at one more example. A graphic designer created a logo on 8.5 by 11-inch paper. In order to be placed on a business card, the logo needs to be 1 7/10 by 2 1/5 inches. So I've kind of drawn those two situations here for you. We want to know what the scale factor is. So in this situation, pick either your length or your width. So you can compare the lengths or you can compare the widths, but make sure that you're comparing corresponding sides. For instance, if I want to compare 11 inches, I would want to make sure that that 2 1/5 inches is in my ratio. Now, we want to think about now, what is the pre-image and what is the image, or what is the original and what is the new? It says that she's doing it on 8.5 by 11-inch paper. So this is her pre-image. This is the size that it started out as. She wants to make it smaller to go onto a business card. So this is our image. This is going to be the dilated shape. So we're going to set it up as the image over the pre-image. So I'm going to put 2 1/5 over 11. Now what I have to do is divide these so that I can get a scale factor. You can change 2 1/5 to a decimal, easier to put in the calculator for you. So 2.2 over 11. Then when you do the math, you're just going to be doing 2.2 divided by 11, which gives you a 0.2. That's your scale factor. Okay. 0.2 is 1/5. So your scale factor is 2/10 or 1/5, meaning that this business card is definitely a reduction. It's a fifth of the size of the original. That was the 8.5 by 11-inch paper. We're going to do more examples in class, so thank you for taking your notes and having those ready for the next day.